Hello, my name is Josh Hobart, and I am a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Manual Cutter and Dam Builder tool. This is the third step of the iterative editing process, and is arguably the most important part in developing an accurate stream network. This tool works by the user, that's you, identifying errors within the DEM and flow network, and creating cut and dam lines to correct these. As you can see in these examples, we can have errors where flow paths are not flowing in the right direction, or where they're coming into or out of the watershed, which is not desired. Cut lines are used when an obstruction of flow is present within the DEM, and it needs to be burned through to allow the flow to move. The way this works is a cut line is drawn, shown within the oval, and then the minimum elevation value that falls underneath that line is extracted and applied to all the cells along that line. This will be used in cases where you want to show that there are culverts, or maybe that there's flow will be going under the bridge. The second option is to develop dam lines, which are used when an obstruction to flow is desired but is absent. In this case, when a dam line is drawn, shown again within the oval, the maximum elevation values that fall along that line will be extracted and then applied to all the cells in the DEM that the line crosses. If no cut or dam lines are made, there's a good chance your flow paths are going to be inaccurate. This example shows a DEM where the flow path should be along the dark brown line. Because no edits were made, the actual flow network that we get, shown in black, is just skating across the landscape, which is not realistic or accurate. Although it can be a tedious process, it's very important to go through the DEM one section at a time and evaluate where cut lines or dam lines should be placed very precisely. It has been attempted to just apply the whole hydrologic dataset to a watershed and burn that in as a cut line. However, this is going to result in inaccurate results for later tools, such as the height of channel tool, used later on in the ACPF toolbox. In the profile graph shown, by burning in an entire stream network, we get false channel elevations throughout our DEM. So in the output, it's showing that every bank is 3 to 5 meters higher than the channel, where that's probably not true in reality. Instead, it's much more appropriate to apply small cut lines where they're needed, and only where they're needed. So here we can see a few obstructions caused by roadways that will need to be corrected. We draw short and precise lines across these roadways, connecting the channel to the next channel. When you take your time and make accurate edits, you're going to get accurate results. Here's that same example shown from earlier. But now, the correct height above channel values are given. We have areas that are considered channel, less than 1.5 meters, and so on. To begin the process of creating cut lines and dam lines, we first need to make the feature classes that we can populate. We have ArcGIS Pro open, and we will make the catalog window active on the right side by clicking the catalog tab. Then we will expand our ACPF data folder within the folders section and right-click on the geodatabase. We will then hover over New, which will be at the top of the menu list, and then click on Feature Class, which is the second item in the sublist. We want to give this feature class a name that makes sense. In this case, we are going to start making cut lines, so we will name it Cuts and enter that into the name input box. If you want to leave it as cuts, you may. However, for consistency across the geodatabase, I would add our HUC ID. You may enter an alias if you would like, however it is not required. In the type of features stored in this feature class option, we want to make sure we choose line features since the cuts will be lines. Go to the bottom of the window and click Next. We can add fields to the cuts table if we would like. Some users have added a field for type so that they can say if it's a culvert or some other means for the flow to cross. However, for just the basic cuts, we do not need to do anything, so we can go to the bottom and click Next again. For the coordinate system, we want to make sure we have the same coordinate system as all the other items in our geodatabase. There's an easy way to make sure that this happens. Within the Create Feature Class window, there is a list of XY coordinate systems available. If we expand the layers, it gives us a list of the coordinate systems used by the layers in our map. If we expand NAD 83 UTM Zone 15, we can see the layers in the map from our geodatabase, including our boundary. This is the coordinate system we want, so we will click on NAD 83 UTM Zone 15 to highlight it, and we will verify that it is selected in the current XY that is available above the list. We could continue through the steps to create the feature class. However, we do not need to change anything in the remaining 3 steps. In this case, we can go down to the bottom of the window and click Finish. It'll take a couple seconds to create the feature class, but then it'll be added to the map. Next will be dam lines. There are a couple points that I want to mention about dam lines. We'll use the terms dams and dam lines interchangeably. However, it should be noted that dams or dam lines, in the sense of ACPF, may not necessarily mean a dam in the structural sense. We're using it as a term to block flow. Sometimes this may be a physical dam, but most times it is not. Also, the amount of dams you will add will be far less than the number of cuts. That's if you have any dams at all. There have been many watersheds that I have run where I had 0 dams, and that is okay. For this example watershed, I will let you know that there are a few dams that will need to be placed. So we will follow the same process to create dams as we did for cuts. However, I will not be showing those steps. Once the cut and dam feature classes have been created, we can begin to create our cut lines. For visualization, I have changed the color on the cut and dam lines from the default. To start editing, click on Edit in the top menu bar for ArcGIS Pro. In the Features section of the Edit toolbar, click Create, and this will open the Create Features window in the same area as our Catalog window, our Symbology, or our Geoprocessing windows. To begin creating the features, you will click on either the Cuts layer or the Dams layer to activate editing for that feature. For the rest of this video, I will be showing examples from various parts of this watershed where cuts and dams have been placed. After running the tool, I will go back to those same places to show what it looks like after the tool has been run. If you see multiple items in the table of contents, that is due to needing before and after layers. When you run the tool, you only have one layer. We'll be able to identify areas where cut lines are needed based on the depth grid, which is another term for our impeded flow that we developed using said Identify Impeded Flow tool. We can see in our map a few depressions that will probably be drained because they are backing up due to this road. We'll zoom in until we can start to see some of the deepest spots or lowest elevations within these depressions, shown here in dark blue. These spots will show up due to the depth grid using DRA statistics for its symbology. To create the cut line, we will make sure that our cuts are our selected feature class within the Create Features window. And we will simply click the lowest point on the side containing the impeded flow and to a point across the blocking feature, be it a roadway, driveway, field drive, or something else. To finish the cut, we will be looking for a spot that is lower than where our cut began. One way to view this is to turn on map tips for our DEM. In the table of contents, we will right-click on our DEM and choose Properties from the bottom of the list. In the Layer Properties window, click Display on the left side of the window. The only option that we are presented with is Show Map Tips. We want to check this box and click OK at the bottom of the window. This will allow us to see the elevation value of the cell from our DEM at the point where our mouse is hovering over. This can only be seen if our DEM is turned on, even if it is not visible due to another layer, such as our map. When we hover over the darkest part of our depression, we can find the lowest value and click once to start the line. We can see that these cells are 23,330. These ones are slightly higher. And so we will start our cut line by clicking in one of those 23,330 cells. If we turn off the hill shade, we are left with our DEM that is on. We can see that our roadway is white because it is a higher elevation. We will move our mouse over to the other side of the road towards the lower blacker area of the DEM. Once we have a spot that is lower than where we started, such as this is 23,323, we will double click to end the line. We can verify this using some aerial imagery that I have added into this map. If we turn off depth grid and turn off the DEM, we can see our cut is in the stream channel as it is coming out of a likely culvert. Another thing to keep in mind, you will want to zoom in a decent distance to get the most accurate cut. If we were to have made this cut zoomed out farther, our cut may have ended in the road and the impeded flow would still be there after running the tool. This is the most common mistake that I have seen users make when it comes to cuts. In this area, we also have some driveways and field entrances that will need to be cut. We can zoom back out and continue painting through our watershed, creating cuts where we find areas of impeded flow. One word of advice: when you're creating your cut lines, it is best to start in one corner of the watershed and work your way across, moving in a systematic way all the way through the watershed to make sure you don't miss any spots. I have seen users utilize township lines or create a fishnet to make sure they are hitting all parts of the watershed. As you pan through your watershed, you do not want to limit your cuts to only within your watershed boundary. There will be situations where the flow is going the opposite direction than it should be. In this example, the flow along the watershed boundary in this yellow color is flowing east into our watershed. However, there's a large impeded flow between the boundary and the road to the west. It is likely that the flow should go under the road and to the west. This is a situation where we put a cut outside of our boundary. These outside cuts will allow for a more accurate drainage area for our watershed. Most cuts are going to occur along roads, including driveways and crop equipment field entrances. There will be instances where we will find what appears to be an impediment. In this example, we have impeded flow with flat edges. Given that there is a series of impeded flow, if we look at the hillshade, we can see a set of wascobs have already been built in this field. Wascobs, terraces, and pond dams are cases where we will not place cuts as these structures are placed for flow management already. Sometimes there are places that will look like these cases at first glance. Here's an example where we have a large depth grid in the middle of a field. Given that it is in the middle of a field, we may believe that it is a terrace or dam for a wetland. However, with a closer look, we can see that this impeded flow is actually caused by a field driveway that is going through the field. Another example of areas where cuts are not needed are natural depressions. The pit fill hole punch process removes the smaller depressions and leaves the larger ones. In this area, we can see larger depressions in the field based on the darker colors. We will not add cuts to these areas as they are naturally occurring with no man-made structure blocking the flow. These are likely to be seen in flat floodplains such as this area. When it comes to cities, less cuts will be needed. There are many reasons for this. One is that it's not agriculture, so the flow within a city is not going to affect our results. Another is that a lot of the impeded flow does not allow for cuts to be effective. LiDAR will return off of buildings and trees, so elevation change within a city does not allow for proper flow. Cuts along visible waterways should still be added to allow for the proper contributing area into the waterway. We have a large waterway along the east side of our screen. I have turned on the cuts that I've already created, and we can see them in this waterway as the yellow lines. However, there are no cuts on the blocked flows to the northwest. Here's an area where a dam is needed. There's a stream channel that runs next to the main river. However, our flow hops out of the stream and into the river, and a new flow continues in the stream. From the imagery, we know that this is one continuous flow through the stream. We will place a dam just below the stream to block the flow from going into the river, forcing it to stay in the stream channel. The location of this dam is the blue line that is between the stream and the river. Dams will most commonly be needed when the watershed has its main channel entering and or exiting via a large water body, be it a river or a lake. A watershed can only have one entrance to and one exit from the main channel. We have moved to the source of our watershed, which contains a large river running through it. We currently have two flows into our main channel. One that is within the main channel, and one that is coming from the outside. This flow from the outside likely stays within this other watershed and doesn't flow directly into our watershed. We will need to place a dam to force it into the main channel above where it currently enters the channel. We would like to keep dams as small as possible so we are not modifying the DEM more than we need to. However, this situation needs a larger dam to divert the flow to the proper location. If we turn on our dams, we can see that the dam in blue is where we would be placing it to force the flow up to where the entrance into the watershed should be. It may take a couple times to get the flow properly flowing. This is one reason why the hydro conditioning process is iterative. I'm going to touch on a couple of resources that may assist in producing your cuts. There is a possibility that your local GIS group or state agency, such as your Department of Transportation, may have a culverts line layer available. This would be a good start to your cuts layer, and there are a couple things to note. You will want to continue to pan through your watershed as verification is likely needed on these lines. Not necessarily for their location, but for their length. Remember that our cuts need to completely cross our impediments, and there is a possibility that the provided layer does not. Also, there is the possibility that some cuts were missed depending on the criteria for inclusion into the initial dataset. Another useful tool is Google Maps Street View. Given the detail that can be seen in the imagery produced at Street View, it can be useful, especially for areas where you cannot determine which way the flow should be going. This method is not useful in a lot of rural areas as there is no street view. In this example, we have a large impeded flow at the intersection of a highway and county road. Since this is an intersection, we can assume that there is a culvert going under one of these roads. However, the aerial imagery does not show us where the flow should be going. By utilizing Google Maps for this area, we can see where the culvert is. I have found this area on Google Maps. We can see the church to the west as the reference point. We can click and hold on the person in the lower right corner of the window, and we can see that the road turns blue, so we know that there is street view. We can place him at this intersection. If we look towards the south, we can see a small area of tall grass along this county road. This is most likely where the culvert is, as the homeowner cannot get the mower against the culvert. We will place our cut across the county road at this intersection. As we can see here in this yellow line. You may be asking if the number of cuts you have made is enough, and I cannot answer that. There is no particular number that will be the correct answer. Every user determines if there is enough differently. Even some of the ACPF creators have different numbers of cuts for the same watershed. The key thing to remember is not the amount, but the proper placement of your cuts to make sure your flow is proper. Once we are satisfied with the cuts that we've made, we can start running the tool. We will open the catalog window on the right side of the window if it isn't already open by clicking the catalog tab. Expand our ACPF toolbox and expand DEM preparation. The manual cutter dam builder tool will be the last tool within this drawer. Double click it to open. We will see a lot of input boxes for this tool. We will be filling in 4 of them. The rest will be for outputs. The first input are our cut lines. Since our cuts are in our map, we can choose the cuts layer from the first drop-down. We will do the same in the second drop-down with our dams layer, as the second input is for our dams. If you are running this tool on your own watershed, you may not have this layer, and that is okay. It is an optional layer. The third input is our unfilled DEM. This is going to be the pit-filled DEM, so we will choose that layer from the drop-down under the input unfilled DEM. This will automatically populate our outputs. We'll notice our first output is a new DEM. This is going to be the DEM that has been hydro-conditioned using the cut lines, and if you had them, dam lines. The other outputs are a new filled DEM, a new float direction, new flow accumulation, and new hill shape. These will be created using this new DEM, so the D8 terrain processing is going to be run again with this new unfilled DEM. And finally, we'll add our Z factor of 0.01. We'll then go to the Run button at the bottom of the window, click it, and wait. The reason we call this an iterative process is because once the manual cutter and dam builder tool finishes running, we'll need to go back and rerun the Identifying Impeded Flow tool and the Visualize Flow Paths tool to see if the modifications that we made were enough to create the errors within the DEM. If not, we'll have to add more cut lines or more dam lines and rerun all 3 of the tools again to make sure that these errors have been corrected and we have a finished hydro-conditioned DEM. Once the manual cutter and dam builder tool is finished running, all of our updated outputs have been added to our map, including our new DEM titled New DEM within the table of contents. As I was just saying, we're not quite done yet. If we go back to an area where we had problems previously and made cut lines, we can see that our flow network has not been adjusted yet. This also goes for our impeded flow. However, this cannot be seen because of the new layers that have been added to our map. We'll need to drag the depth grid above those new layers, and once again we can see that it has not cleared up. This is why we need to rerun these tools. We will open the catalog window on the right side of the window if it isn't already open by clicking the catalog tab. We will double click on identify impeded flow within our DEM preparation. For the input unfilled DEM input dropdown, we will choose our new DEM as this is our conditioned DEM with our cuts and dams. We can see a small yellow warning icon next to output depth grid. This is due to the feature class already existing within our geodatabase. If you remember when we set our settings in ArcGIS Pro, we checked the box to overwrite existing layers. That setting is allowing us to proceed. If the checkbox was not checked, we would have a red X and would not be able to proceed until we remove this layer from our geodatabase. We will click Run again at the bottom of the window. Once that tool has rerun, we will go back to the catalog window and double click on Visualize Flow Paths. We will need to enter our new flow accumulation raster from our map into the dropdown. It'll populate with our new flow direction. We want to use the same acreage for our area threshold that we did before, so we will enter 2. We'll be presented with the yellow warning again for our output flow paths tool, which is fine. And we will go down to the bottom and click Run again. Now that the Visualize Flow Paths tool has rerun using our new DEM, let's take a look at some of the areas that we've looked at earlier in our video. Here we have our flow that had been blocked by the road with the large depth grid, the flow paths looking like a skating rink. And if we turn off our original depth grid and our original flow paths and turn on the new depth grid and new flow paths that were created from the new DEM, we can see that the depth grid is all gone. The flow is now going as it should, and our flow paths, we can see our one line for our singular flow path right where we would expect it to be according to the hill shape. Next, let's take a look at the cuts that were on the outside of our boundary. Once again, our flow is flowing into our boundary where it should probably be flowing underneath this road, as we can see that the flow is impacted by the road. Turn off our original, turn on our new, and now we can see that the large area of impeded flow has been removed. There's still some there, and that is most likely just a natural depression. And we can see that the flow is now going as it should to the west underneath this road. We have a little bit of this flow that is within our boundary that is now flowing out, and that is fine. It is just a small bit. It is not a large amount as we saw before. The next example was the middle of the field. Once again, large impoundment. We have the skating rink straight lines. If we turn off our originals and then the new, the impeded flow is now all disappeared, and now the flow path is following through where we see these streams within the hill shape. This example was the city where we did not have any of the cuts on the impeded flow within the city, except for where we had our main waterway that was running along the east side. So we can see that the flow still appears to be the same until it gets to the main waterway, where it is now our one line that is following along through the hillshade. Next, we have our area where we needed to put the dam in to make sure that the stream stays within its stream banks and not overtopping into our river. And now we can see that that stream does in fact stay within the stream banks where it's supposed to be and is not flowing within the river. We'll head up to the source of our watershed, where we had the two flow lines that were coming into our major river waterway. And looking after we have made our hydro conditioning, this flow now is following along the dam and goes to a point that is just within our original boundary. This is workable since it is essentially in the same spot as our boundary, and so there's no more edits that we need to deal with in this situation. The last example we'll take a look at again is the area where we utilized Google Maps to see where the culvert actually was. Once again, we were looking at this area on the south side of the intersection. Turn on our new flow paths and depth grid. We can see that our impeded flow now has disappeared, and we actually now have a flow line that is occurring on the south side of this road within this ditch. The whole process of creating cut lines and rerunning your flow network and impeded flow may take a few tries. It's an iterative process. Every time that you run the manual cutter and dam builder tool, whether you're adding more cut lines or maybe removing some cut lines that were inappropriate, you're always going to put in your original DEM into the unfilled DEM portion of the tool. And you'll be getting new outputs every time you run it. In later tools, whenever it asks for an unfilled DEM, anytime after you've completed hydro conditioning, you're going to want to enter the new DEM that has been created from the manual cutter dam builder tool. This whole process of hydro conditioning the watershed may take a while, from a few hours to a couple days, and that's alright. You want to make sure that you have the most accurate flow network that you can have. To recap, we discussed how and where to place cut and dam lines. We ran the manual cutter dam builder tool to produce a new DEM. We also finished our iterative process by rerunning identify impeded flow and visualize flow paths using our new DEM.